Thanks everyone for being here today. We're looking forward to a great discussion on from a diverse set of industries on how robots are being used today in these different industries, and the ways in which we can see them improving the quality of life and the type of work in which they're doing, and the performance improvements that we have. So we are going to discuss through the impact that the use of these robots have had in these sectors, the new technologies which are coming and how they could be disruptive in those industries, and the opportunities to work together across industry and across technologies. So basically, to start off, I've been introduced myself, and then just going to run through the panel. So we have Elle, who is the head of technology research at the Intervention Center in the University of Oslo. Also UniversityHospital, sorry. And then we have Adrian Gianni, who is the head of global technologies in iTech services at Subsea 7, based in Houston. And Egil Utheim, who is the founder of Mektron Robotics AS across in Drammen. And also Bernt, Øyvind Børnich, who's CTO of Halodi Robotics. I'll just let everyone introduce themselves in more detail, give you a short intro on who you are and what we are, and then we'll begin on the discussions in the different application cases. So first across to Ole Jakob.
Thanks. I'm Ole Jakob Elle, and as John said, I'm heading a section for technology research at the Intervention Center, Oslo University Hospital. I also have a second position at the Department of Informatics at the University of Oslo. I work with robotics, robotic surgery, navigation in surgery, and sensor fusion and stuff like that. The Intervention Center is a cross-disciplinary research and development center for new surgical methods as a common resource at Oslo University Hospital.
Good afternoon, I'm Adrian Gianni. I'm with Subsea 7. Subsea 7 is an offshore construction company that builds and designs offshore fields. The division that I work for is iTech Services, and our focus is on maintaining those assets and extending the life of those assets. So we use robotics quite heavily, both on the construction side and throughout the life of the asset as well.
Hello, my name is Egil Utheim. I founded Mektron Robotics in 2010. My past experience was in robotics in the standard industries and as in metal or food, and I did the transition into healthcare, collaborating with Ole Jakob into the hospital robotics, and also with robotics for home care use for a shower robot that we'll come into later.
My name is Bernt Børnich. I'm the co-founder and CTO of Halodi Robotics. We build a full-size humanoid robot called Eve, which has the strength and reach of ordinary humans, and with the goal of mass producing to actually bring robotics in the long run into the price point of the consumer sector.
Thanks very much, everyone. Yeah. So first off, getting into this, really like to introduce, based on the topic of today in the life sciences, your experience, Ole Jakob, in the use cases that you know of and you work with within the healthcare sector, and the trends that you see and opportunities there.
Yeah, and what you can see here on the screen is a kind of transition in time that in 1914, actually, a French comic drawer tried to envision the OR, operating room, in 2000. And if you see in the middle there, that is actually the situation today. It's the Da Vinci from Intuitive Surgical, a remote controlled manipulator that performs surgery. The future will probably be more autonomous, more sensors, cognitive reasoning by the robot, learning machine learning techniques in order to do more automatic actions. You can take the next slide. Yeah, I started up working with SUS telemanipulation system there on the left from Computer Motion. They was later bought by Intuitive Surgical and ended up in the Da Vinci system that you have to the right there. And this is actually the robot in surgical duty that you find around the world. It's thousands of those systems in the ORs throughout the world. And mainly they are used to perform surgery on prostate. So they are used to resect, to cut out the prostate when there is prostate cancer. And that was before done open surgery with big openings and using your hands and resection. And then transferred to keyhole surgery. That was very difficult with long, stiff instruments to do the suturing of the urethra and the gallbladder. And then the transition to a robotic system that was mainly made for thoracoscopic bypass surgery, but that was a bit too difficult, so it ended up being suturing in the prostate area. But that have been very beneficial. They do it faster, and it has actually become the most common surgical robotic procedure. The benefits of that is that it filters out the tremor, so that the tremor of the hands of the surgeon will be filtered out, so it's totally stable movements, and you can scale down the movements, so it's more precise, and you have a wonderful visualization with stereoscopic video camera, so that you have the depth image and you see exactly where to place your instruments. But you have no force feedback in the system, so you don't feel the contact force and how much you push with when you kind of make a suture and want to make a knot. You don't know how much you stretch. So you break a lot of sutures and needles in the beginning. So that is kind of the benefits and some of the drawbacks. We also work on tele-operated ultrasound robots in order to be able to kind of transit the primary health care with ultrasound examinations that can go more autonomous, automatic examination, and or with trouble, couple up and connect to an expert at the specialist hospital to remote control that ultrasound examination. And this is a project that we work together with Egil Utheim here that will talk more about that later.
No, it's really great, actually, looking at this. And I know that I've got a long background in oil and gas side of things and working with the ROVs and looking at the pictures here and knowing that the advances that you've made and the manipulation and everything in those areas and the type of operation, there's probably so many synergies with the type of work that Subsea 7 has got going on.
Yeah, this is very similar to the things that we're looking at, that, you know, if you think about the oil and gas industry, that, you know, 30 years ago, 30 years plus, we moved from depths that you could dive at to depths that you had to use robots to perform the work. Initially, the work was very much about replicating what a diver would do. Now it's very much about how do you speed up inspections, how do you do more delicate tasks. So a lot of what we're looking at is very similar to this. In fact, you know, the picture on the left could very easily be somebody controlling an ROV. If you hadn't have told me that this was about a prostate, you know, it could easily be an ROV working, you know, the manipulator on a pipeline or something else. So we see a lot of similarities, and so the challenges that we're faced with today are that we effectively have an ROV with one person working, supported by 100 people on a vessel, you know, 100, 200 miles off the coast, that is costing, you know, $100,000 a day. So the operators are concerned about the health and safety, just the general cost. And so we're being pushed more and more to how do you take those people from offshore? How do you have those remote links? How do you improve the inspections that you're doing? How do you know, we quite often will do an inspection and you won't get a report for a month. How do you speed that up so that the quality of the inspections is better, that you have less false readings, and that now you can use experts on shore to be able to look at the data as well. So we're certainly looking at remote piloting, we're looking at autonomy, we're looking at visual recognition systems, not as a way of replacing people, but as a way of really aiding them that their time is better used, that you can have an expert who's able to look at real anomalies rather than they're spending hours and hours looking through video footage to find that one anomaly.
Mm-hmm. And you're not having that person on the vessel, you're trying to get them further and further away.
Rather than you've got to have, you know, we have a fleet of 30 vessels, so rather than having 30 of these people, you can effectively have one person who sits in a centralized office, is alerted to an anomaly, and then is able to control things or direct things from there.
Mm-hmm.
So we definitely see a lot of similarities with where the healthcare industry is going.
And where you were mentioning as well about the ultrasound, I guess, is similar sort of inspection activities and things like that, and trying to do that remotely. Was it Egil, you mentioned at the start as well?
Yeah.
So.
What we learned together with the intervention center is that it's possible now to have the robot to remotely do interactions where you can then move some of the services out from the hospital to the municipality. Very similar to what you are doing. You're moving some services from one costly space to a less costly space where you can do it. And when you do this change, you will maybe have a 10 times or 100 times saving of costs when you can do the services closer to the patient at a lower cost of hours. However, in healthcare, we have the problems of doing this transformation because the money is sent to the hospital. It's not sent to the municipality to do these ultrasound examinations. So there is no incentives for them to implement a costly examination system, although the society would benefit from it. So here we have a barrier that we have the technology, it's tested, it's used, but we cannot sell it because there is no way for us to have it refunded. So that is one of the barriers that we might see. But maybe in the future when, if you look 2 slides forward, not the next, but the fourth one, where we see that at the moment we're in a quite healthy situation where we have a balance between the supply and the demand, where we have enough hands to take care of people. But in the future, there'll be a less supply of healthcare workers, and the need will grow. And if we're able then to do a digital transformation where the robot is a part of it, we put the machines in the top to take off that load, and we make the humans do the human tasks. That means that we will still have human hands caring with people, doing examinations, or like the shower robot that we're working on, but we need to divide the works differently. And that means that we not only have to do advances in technology, but we have to do advances in how we refund these solutions, but also how we organize our work. And that we need the nurses to be trained in technology so they are able to offload some of their work in that respect. I think that's what you're looking at also, that you're trying to push the robot closer to the humans.
Yeah, so we kind of come into this where you talk about today there is no force interaction, and our robot is quite different from today's robot. It's built from the bottom up to do force interaction, and that makes it much more able to interact with unstructured environments like your home or patients which are moving around. And a couple of really good use cases are exactly the ultrasound, which would require like good contact, and also the assisted showering. And we come into this like bringing both the capability of the robots up, but also bringing the cost down by getting volume up. So today these specialized robots are extremely expensive. But if you can make a robot which in general can handle both the medical cases, the industrial cases, and in the long run the home cases, the price really comes down. And then you can gradually transition from remote control, like we have today, and into more automated. So for example, if we use our robot for the shower, then that can be done autonomously, but you might still have someone log on to help unload groceries in the refrigerator, or turn off the stove if it was forgotten, or these kind of tasks, and you move them gradually over to automated systems.
Mm-hmm. Are there any challenges from having these kind of the remote operation, the remote control system that I think both of you are talking about, Adrian and both yourself, Bernt, on the use of having a remote system far away being operated by a user? What are the kind of technical challenges which are preventing us from those today? Are they similar in both
force
areas?
interaction is kind of the key. So if you can have force interaction on both sides, so what we do is we mirror the robots. So the robot will be holding your hand. So when you move your hand, you can feel what the robot is feeling on the other side. So you have full movement
control
of both your arms and feeling the other side. And then you kind of close the gap where you don't need the amount of training. It becomes very natural when you get 3D vision and you do that. And you don't have the training needed to, for example, use the Da Vinci robot, like you say, which is really a skill in itself that you need to learn. The challenge then is to build a robot that can do this while being cheap, and also to handle the latency. So controlling remotely with force interaction is very demanding on the latency, but that can be solved both through software and mechanics, but also through infrastructure. And you see the industry now is changing focus a lot from bandwidth to latency. If you look at 5G, for example, then it's mainly about the latency. It's not about higher bandwidth. And
that was one of the areas that I was kind of really interested when you're saying about it. And of course, over like the long stretches that you might have for oil and gas, for example, significant distances over maybe limited bandwidth. Is that somewhere where other technologies are coming in, so automation or other AI type applications?
We see that the time delay is a serious issue for us, especially with, it's okay if you've got a hardwired solution, but as soon as you move away from that and you're using wireless subsea, the time delay is going to be a real issue. We've developed an autonomous inspection vehicle, so this is where you can program it, it runs off, it'll do a series of inspections and come back and then download all the information. What we find there is that it's industry's desire to take it on. It's the unknown, it's a disruptor, it's not how you do things today that gives people that fear that, our robot's taking over the world. No, they're not. It's simply, aiding you in how you do things. But certainly, we found that with the autonomous vehicle, we've had this in development for probably 7 years. The platform is robust. The problem is that how do you get people to want to change when it's going to remove their job, and effectively they're going to have to do something else in the future.
In surgery, automation is a delicate thing. It's not there yet. There have been some attempts through EU-funded projects. We were in one called Intelligent Surgical Robotics. We tried to automate that to put in a needle and take a tissue sample at a tumor, and to cut in a controlled manner in order to open up a surgical area, and also to suture that wound back in a controlled manner by cognitive algorithms and machine learning techniques. But that is because the human body is, and the organs is deforming, and things are moving due to heartbeat and to breathing, and it is so important that you do exactly what you are supposed to do. So we need to know that we always exactly know the environment and where things are at a certain time in order to move there with the robot, of course. But when it comes to external ultrasound examination, for example, that we have been talking about here, then it's not that dangerous anymore, and it's we can use machine learning in order to find a certain image plane and try to keep that in order to have the operator concentrating on other things, and the robot is kind of following the visual plane that you want to use when you are inserting devices and stuff like that, for example. So it can be gradually implemented in systems in the future.
So you prove it out on a safe ground and kind of build up that the capability.
Yeah,
I guess
exactly.
one of the big risks I was thinking with the latency, of course, is if the operator's doing one thing and the robot's doing something else 10 seconds later, then it's you can quickly end up in these challenging situations. And I guess that's where the autonomy, the ability to do these sorts of control scenarios that you're talking about is essential.
Exactly.
And I think that's where the really interesting development areas come in, and great synergies with things like the subsea, doing inspection, being able to prove all the external influences there as well, the robots being moved around by the current, say, or the you having to adapt to do the sort of activities that you're talking about. But I think during that discussion just there with all these great opportunities, one thing that always comes in is the question about the jobs and people's concerns about the jobs. And I'm not sure who wants to take on that question, but it's one of these ones. How do you see it in your industry? Has it robotics have been introduced in surgery for a while, I guess, and has there been an impact there? What's the changes that this has brought in that space?
When it comes to reduction of jobs, it has been none, I think. I mean, the surgeon is there actually performing the surgery just through a advanced joystick. The only thing was maybe if you use a robot for assisting, holding a device or an instrument, which can be controlled in one type of interface by the main surgeons, so that the assisting surgeon is not needed anymore. But that is also one of the ways that surgeons train each other. They have kind of the saying that it is see one, do one, teach one. And you lose that aspect. So in private clinics, it might be a benefit. In university hospitals, it's not the same. There you actually need that assistant doing kind of this as part of the training.
Yeah.
But I think if you look at the aircraft industry, you know, pilots initially train a lot on flying planes, but they keep up their maintenance and their type provisions by using simulators. And you know, certainly the oil and gas industry has moved towards that as well. We use a lot of simulators now to plan out operations, to keep the proficiency of pilots up. Is that something that would transfer over into the health industry as well?
That's absolutely correct. And it's more and more surgical trainers, like box trainers, the low-cost versions, and the virtual reality trainers for surgical actions. So that is coming more and more. And in other countries, you see more and more that you actually have to train before you go to a patient and do surgery. And you have to pass a certain threshold in order to be allowed to do surgery, and you have to do that regularly in order to keep that allowance to perform. So absolutely, that is coming more and more and will be there.
I definitely don't see, though, the job issue as one that politicians like to make it into. I think, you know, I went to a conference in San Francisco, and the director from Lyft, the autonomous truck company, was there, and the first question that he was asked was, so when are there not going to be any more truck drivers? And he said, you're thinking about this completely the wrong way. You know, at the moment, there's a shortage of truck drivers. For every truck traveling across the US, there's typically 2 drivers, and one sleeps while the other one works. What autonomous trucks allows you to do is have one driver when the driver needs to rest, you know, when there's a high likelihood that he's going to have an accident, when he's tired, he's on a very monotonous road driving, you know, long distances. That's when the accidents are going to happen. Have the autonomous truck do it as a co-pilot. The driver can then sleep. Then when you get to built-up areas where you need that human interaction, you need the judgment of an experienced driver to take over. The driver's there, he's rested and can do it. We see this in the oil industry that, we typically have, 2 ROV pilots plus a supervisor for every shift. But if you're traveling along a pipeline, it's very monotonous, boring work. Have the ROV simply do it by itself. Have the autopilot function, have the ability where the autonomy will take over and do that. And so this is where we have to look instead that you're utilizing skills for what they're the only person who can do it. This is their expertise, rather than you're fatiguing them with low-value tasks that they don't really want to do.
Yeah, I think we just need to map out the high-volume tasks that could be automated and look into the more cognitive tasks that humans need to be done, and just divide the work and put the robots where they are best and put the humans where they are the best. That means that we maybe also need to reorganize our whole communities, our services. So if we would have a digital infrastructure that would be able to match this in a better way, we could maybe do away with some of the extra works, for instance, the nurses that has to drive home to a patient to give medicine or to care of them. If you have a self-driving truck that could pick them up to a place, so you could take away some of the driving times. There are many ways you can reorganize your services when you have the robot that could do some of those tasks.
Yeah, we also get this question a lot because we disrupt on work in general, so we're not purely medical, it's just one of the use cases. But I think if you look at the other way around, you could say our brain is the most amazing thing ever created by anything. And it's so wasteful to have that do menial tasks 10 hours a day. And we need people to do things that you can't do as a machine. There are so many needs in society for people to do better things than stacking boxes or, and the shower is a good example because it's typically something that where the patient would prefer the privacy. They would much rather sit down and talk to the nurse afterwards about some problem than have them in the shower. And but I think like in the long run, there will be a need for moving the workforce. You already see this really well in the digital space, where AI has automated a lot of tasks, but what you're currently lacking is the cheap enough physical actuator to start automating things in the real world. And once you have that, both with robots and with autonomous cars, then of course you will need to move a lot of those workers into other sectors. But it's not like we can't use this marvelous machine for something else. So I think it will be a better society.
And new jobs will come. Yeah. 20 years ago, there was no such thing as a Facebook manager. If you'd have said that there was going to be somebody who was managing your online profile for a company, you'd have thought they were mad.
Absolutely.
So new jobs will come, and if you even go back at the turn of not this century, the last century, where most people worked in farming, and then the advances in farming allowed people to move out of that. The workforces became more productive. So yes, there will be a change in how people do things, but the advances will open up so much more for us.
You also touched on the kind of tasks that we could actually automate and improve safety, things like driving, the nurses driving around to go and visit people, and road traffic accidents are probably one of the highest risk areas that people can have in the daily work. I know that Shell, one of the examples from oil and gas, their biggest accident rate was in the road traffic accident side rather than any of the operational side of things, and I'm sure it rings true with many of the others. So being able to also address some of these key features can be very disruptive for the quality of life, to improve the actual kind of working space for everyone to be there. So it's an exciting place to be in. But the areas that we talked about as well, we kind of ran through here some of the examples. There's huge synergies, I think, between oil and gas, between the medical side, these applications, the development and the needs for doing this remote autonomy in many aspects, or maybe improved dexterity within the operations going on, which is also something required there. Other opportunities to work together. Where's the best place for industry or the technology companies such as Egil and Bernt to actually think about, where can they develop these things in a safe environment? Where would be a good proving ground, and what way would be to take things forward?
I definitely think that the oil and gas industry is, it's a very different sphere to the healthcare, though if you look in very broad terms, and I don't want to demean the healthcare industry in any way, that I'm looking at how do I manage an asset. That's effectively what a healthcare worker is doing as well. The only difference is that mine is fairly dumb and doesn't move. Yours is the most complex system known out there. So, what the oil and gas industry brings, especially the subsea part, is that we've got a very harsh environment where reliability is key. But the impact of what we do, if we damage a pipeline, then we can repair it. So long as, the barriers are typically in place that it's a very benign environment when we're working on it, which is an ideal proving ground for a lot of technologies. That if you can prove in a very highly dynamic environment that it has the reliability, it has the ability, it's robust, then now transferring that back into the healthcare industry is a lot easier.
Sounds like an exciting place to collaborate on. The new synergies between the companies and the sorts of technologies being worked on together.
Actually, I would say that most of my time is now spent looking at things in the healthcare industry, because if you look at our inspection techniques, we're using ultrasonics, we're using X-rays, we're using MRIs, we're using things that every day are used in hospitals and have become so familiar that now we're trying to marinize them and put them into the oil and gas. And then, the most exciting thing at the moment for me is probably the use of artificial intelligence that you see for cancer detection and diabetes detection, where you take a biopsy and now an artificial intelligence machine is able to detect the cancer, and you're getting higher success rates than a pathologist looking at it. This is directly transferable to our inspections that we look at that would really give us huge advances.
You have the possibility of combining a lot of information, of course, using AI techniques like deep learning and search, like Dr. Watson's IBM machine, where you can combine gene information, tissue sample, images, things written in the clinical protocols, and combine this for a lot of patients. And for a single doctor, it's impossible to have all these different varieties in their head, but for a computer to run through that and learn from that, and then you get a new patient and you see a pattern. That is the case. It's a possibility that kind of have a possibility that goes beyond the human possibilities, actually. So to use that, both in oil and gas and in medicine, I think it's a future asset.
Yeah, and also, like you say, it's two different things. Humans are really good at some things, machines are really good at other things. And what's very interesting going forward now, not only with our robot, but robots in general, as they become more capable and come down in price, is how you can see that transition from the pure digital domain and into the physical domain, which for some surgery robots it happens, but as you say, that's too invasive, so it's not like a playground to test out new things. But that revolution hasn't really started yet, so we don't know where it's going, because today it doesn't make economical sense, because the robots are too expensive. But you have the same thing there, where the machines will be really good at some things, but they will probably be assisted by humans for most of the tasks, because we are much better at other things. So this interaction between human and machine is very interesting.
Oh, great. I think looking at the time, I think there's been, I know that we could go on. We start looking into different areas, and it's a really interesting and exciting area with in both medical, oil and gas, and many, many other fields as well, about how this could have an impact. But I was wondering if there might be any questions from the audience before we wrap up here. So just if anyone has anything to add. No questions? Any questions? you have a picture of Eve? I think Eve will be presented on the stage.
I'm going straight
next
to
door.
present Eve after this one, so I didn't have time to put up some pictures. Well,
No, but that's great. So
but that's a great question. Should have had a picture of Eve. Eve is not something we're planning on building. There's a full version of Eve standing in our lab, currently working. So it's still at the prototype stage, but it's at the same time it's a proven technology that needs to be scaled to actually reach the market and the price point that we're targeting. Well, that depends on when. It's like you have a cost roadmap, but the ultimate target is to mass produce it so people will buy it as something you have at home. So then it would be a price that roughly a very expensive vacuum cleaner.
Sophie?
Sophie, no, I don't think so. No.
Handsome Medical, yeah.
We have a picture of Sophie. Maybe I've seen it, but forgotten. There's many medical robots. Yeah. Yeah. What's typically the case? Now I'm not commenting on Sophie Sophie specifically, but in general, if you look at what we call like the social robots that are coming now, there are a lot of social robots coming, and what puts us apart is that we actually have 10 kilograms of payload per arm, and we have full torque mode robot who can do force interaction. And if you look at these social robots, they can socialize, but they can't do real work because they're lacking the strength and dexterity to do real work. And they're a very, very good start because there's very much to be explored in the interaction, human-machine interaction between humans and machines. But at least I firmly believe that to have a good use case economically in the long run, you need to be able to do real physical work. And I don't know about Sophie, but in general, at least all the social robots I've seen, they don't have payloads that make them fully usable robots. Well, it kind of answers itself because we're not purely targeting medical. We're targeting, in general, disruption on work. And everything around us is built for us. So when we build a robot that has the same dexterity and movement patterns and length of arms, height, same joint mobility, strength, everything that we have as a human, it's not just like it's cool to build a humanoid robot. Our entire world around us is adapted to that form factor. So if you want, and buildings change so slowly, so you can't like expect the environment to adapt to the robot. In an operation room you might, but like if you want to have it at home, some elderly people at home, then you have to fit into the homes that are already there, and you have to be able to reach the kitchen cabinet. You have to be able to turn on the stove or put stuff in the dishwasher, and then you basically need to copy the human physique. While still and the trick, of course, is that being able to do that while still being safe, which is the challenge, and why we have a different approach using soft joints, so you are passively safe even if the controller is wrong. So,
okay, thank you very much. I looked at the audience while you were discussing, and there weren't anybody who wasn't staring straight at you. I think that's a good sign. Thank you very much.
Thank you. I'd like to thank Bernt, Egil, Adrian, and Ole Jakob for great discussions. Thanks very much, guys.
Thank you.
Yeah.